Okay, so this would be our topic for today, simple connections. So how would we know if we have a simple connections? Okay, if the line of action of the resultant force to be resisted passes through the center of gravity of the connection, so basically, it's on the center of gravity location of the connectors. Okay, let's say if you will take a look of this figure letter A here, so we have a double lap joint. It is connected using 6 pieces of bolts, and these bolts have equal diameters and they are equally spaced. So by inspection, the center of gravity of these 6 bolts would be somewhere here, nasa gitna. And doon nagpapass through yung force. No? If the load or if the force passes through the center of gravity of the group of connections, that connection is said to be simple. For simple connection, each part of the connection is assumed to resist an equal share of the load. Ibig sabihin, kapag ka-RU yung load, so yung isang bolt, kung 6 sila, would be RU divided by 6. And the connection is called a simple connection. So letter B figure also shows us a simple connection. We have a single lap joint. Again, using 6 pieces of bolts, equally spaced, the same diameter. So by inspection, the centroid is here, and that is where the line of action of the load passes through. Likewise, on figure letter C, this time we have a welded connection. So we have a top plate connected to the bottom plate using welds. So this is a longitudinal weld. This is another longitudinal weld. Longitudinal welds are welds applied which is parallel to the direction of the load. Tapos itong length of weld naman dito, which is perpendicular to the direction of the load, ang tawag naman doon ay transverse weld. So pwedeng combination siya ng longitudinal tsaka transverse weld. Okay, so if you will locate the center of gravity of these welds, di ba, nandito siya because it is symmetrical about the x-axis, and that is where the line of action of the RU is passing through. Therefore, this connection is also considered as a simple connection din. So pag sinabing simple connection, it's more of direct shear force lang. No? So wala tayong eccentricity or wala rin tayong moment na i-consider dun sa connectors. So these are the types of connection, steel connections that we could have. It could be riveted or bolted connections. Advantages would be it is easy method of connecting members on site. Field bolting is cheaper than field welding. Mas mura pagka bolted riveted. Ang disadvantage lang ng paggamit ng riveted or bolted is that you have to drill or punch holes. And as we have learned from module number 1, whenever we drill holes, diba, there would be a reduction of the area. Thus, it also reduces the strength of the member. When it comes to welded connections naman, it has its advantages such that it eliminates the need for punching and drilling, of course, and it simplifies complicated joints. So mas madaling i-connect kapag ka mga welding. Kasi you don't have to consider yung mga spacing between connectors. No? So medyo komplikado yan when it comes to bolt connections. For the disadvantages of welded connection naman, greater level of skill is required for welding than bolting. More expensive siya compared to bolting, and weld inspection is required and is expensive. Kasi pagka welding, it requires skilled workers, skilled welders to conduct this welding. So meron tayong mga available trainings for skilled welders na binibigay ng TESDA or some private agencies, no? So kailangan talaga ng greater level of skill when we do welding. So these are the different types of bolted connections. Basically, there are 5. I have here 5. So first is shear connection, moment connection. Pagka shear connection, this is more of the pin connection or hinge. Okay? Pagka moment connection, basically the detail is more of fixed or rigid. Okay? So, pwede siyang maging single angle, double angle, shear plate, etc. Ito naman, pagka sa moment connection, it could be flange, plate, direct weld, end plate. So, basically, nagdidepende yan dun sa detalye ng connection. Bolted connection can be also used for truss connection or cross bracings. Splicing connection kapag magdudugtong ka, let's say for a certain beam na masyadong mahaba yung span, hindi sapat yung commercial size ng span na available, so you have to do splicing. And of course, we have the column based plate. So I have here the pictures of the different types of connections. So for the shear connection, as you can see, here is the gear there, kasi ito yung beam. So basically, yung web part lang ng beam ang nakakonekta dun sa web part din ng gear there using a plate. Okay? It could be a single plate or it could be a single angle, or it could be a double angle kapag may angular din na nakalagay dun sa kabila. It could be shear plate tab. So like for this example, again, yung web lang din ng beam ang nakakonekta dun sa column. Yung flanges ng beam walang connection. Kaya that makes it as a shear connection, para siya naka-hinge or pin lang. Kapag ka moment resisting connection, lahat ng elements ng beam ay nakakonekta dun sa column or dun sa gear din. Pati yung mga flanges dapat may connection. Shear end plate. Okay, as you can see from this detailed, again, ito yung beam, tapos ito yung web ng beam, connected lang din sa web ng gear there. Okay, tapos naka-cope. Pansin nyo rito, naka-cope yung beam. Kaya ang tawag dyan, cope beam. Parang tinatapyas yung lower flange para pumasok yung web dun sa gear there. Kasi pag hindi mo tinapyas yung lower flange, hindi papasok yung web ng beam dun sa loob ng web ng gear there. Ganun din yung sa taas, yung upper flange. Kung mapapansin mo yung upper flange ng beam, kinope din siya, naka-cope din siya, para maipasok yung web. So, ang tawag dyan ay cope beam. Seat plates. Seat plate naman, parang yung web ng beam, naka-weld lang siya directly dun sa web ng column. Tapos may seat plate sa ilalim, pwede rin tayo magkaroon ng seat plate sa ibabaw. Seat plates are just angular sections. Pansinin mo kapag moment connections naman. Pagka moment connections, lahat ng elements ng beam ay nakakonekta dun sa, pwedeng sa column, pwedeng sa gear there. Nakakonekta siya dun sa web part, nakakonekta rin siya sa upper flange, dun din sa lower flange. So all of its elements are connected. Kaya moment connection siya. Flange plate ang tawag dyan kasi we are using steel plate dun sa flanges to connect them. Directly welded. Directly welded. Yung cross-section, yung cross-section ng beam ay directly welded dun sa column flange. Tapos dinagdagan pa ng angular section dun to connect the web of the beam. So all of its element ulit are connected. So it could be an end plate din. So ito yung beam. Tapos sa dulo ng beam section, meron siyang end plate. Ito yung end plate. Tapos yung end plate, naka-bolt naman dun sa flange ng column. Bolted connection can be also used for bracings. Ito, yung mga cross bracings na yan. Or also for trusses. Ito yung bottom cord. Diba? Ito yung bottom cord. Tapos ito naman yung mga web members. It would be very hard for us to connect the web members to the bottom cord kasi maliit yung area ng bottom cord. Usually, ang bottom cord are made of double angle lang. So, kumbaga yung contact area maliit. So, that's why we use gusset plate. We provide gusset plate. Ito naman yung splice. Kapag yung desired length ng member mo is masyadong mahaba, na greater than dun sa commercial size, so magdudugtong ka. So pagka magdudugtong ka ng member, it has to be spliced like this. It should be rigid. As you can see, naka-splice sa web, naka-splice sa top flange, naka-splice din sa lower flange. At yung pag-splice niya, if you will notice, double lap joint. Doble. Doble yung plate na ipinapalaman dun sa pinaka-flange. Ganun din sa web. So kapag ganito yung detalye ng splicing mo, this is more of a rigid splice connection. So as if parang diretso yung beam mo, walang putol. May moment din siya. And of course, we have the column-based connections. Now, how do we analyze? How do we analyze in terms of strength requirements? Okay, so during our module 1, we have analyzed connections against tension. Ibig sabihin, ina-analyze natin yung mga connection on the strength of the member. This time, hindi na natin uulitin or hindi na natin i-discuss yung strength ng member against tension, but rather we're going to analyze other modes of failure. Ano pa ba yung mga posibleng mangyaring failure ng connection? Sa module number 1, ang kinonsider nating failures are yung GSY at NSF. These are failures on the tension member. Okay, so this time, we will have una, shear strength requirement or shear strength limit state. And that means yung pinaka-connector, kunwari yung bolt, mapuputol siya. Pag naputol yung bolt or rivet, that would be shear failure. And the as per AISC again, ganun na naman ulit, no? The design strength should be greater than or equal to the ultimate strength or the load, the factored load. And the resistance factor for connection would be 0.75. 0.75. Okay? So basically, aalamin natin dito is what is R sub N. Okay? So R sub N is the nominal shear strength. And that could be solved from the nominal shear strength, which is provided based on type of bolt or rivet being used. Actually, we have this table here that gives us the FNB or the nominal shear strength of different types of bolts. Binibigay niya yung FNB niya. So basically, sa problem, given yan. I-multiply mo lang siya ng cross-sectional area of the bolt. Siyempre, ang bolt, ang area naman niya is circle. So that would be pi over 4 diameter of the bolt square. Okay, so remember that this would be for single shear and this would be for double shear. So single shear, single lang yung sheared area. Pagka double shear, the sheared area would be doubled. Okay? It would be multiplied by 2. So ganun lang kasimple kapag sa shear strength requirement. FNB times the area of the bolt. So these are example of the commonly used type of bolt. We have the ASTM A307, A325, or the A490. So para rin siyang structural steel yung designation sa way that it is designated with an ASTM. That means it passed through all the requirements. And it is an O-room or a ferrous material followed by these numerical digits. So these are example of bolts. Kung mapapansin mo, yung mga bolts may nut. No? Pwede mo siyang screw, pwede mo siyang tanggalin. Pwede rin siya, may washer din siya to tighten up. Kasi ito naman yung example ng rivet. Pagka rivet, permanent. So once you installed it, no, pagka hinila mo yan, nilock mo niyan, nag-swell out yung pinakadulo niyan, so naglalak na siya. Tapos mapuputol yan dyan. So permanent na. Unlike pagka bolt, you could unscrew, pwede mo tanggalin, pwede mo ibalik. Now, aside from shear strength requirement on bolts, another possible limit state or failure is bearing strength. Okay? So bearing strength. So when it comes to bearing strength requirement, we have to check for the spacing and the edge distance requirements in the connection. So let's take a look of this member. Okay, then kunwari meron siyang bolt dito na naka-insert sa kanya. Ang analysis natin pagka bearing is per bolt, per piraso. Okay, halimbawa may bolt dyan. Okay, so ito yung plate, ito yung bolt kunwari. And kapag hinila mo siya for tension, of course nagkakaroon sila ng contact. And whenever we have contact between two separate bodies, bearing stress is being developed. Diba? Bearing stress is being developed. Okay, now, kapag yung bearing strength, usually kapag bearing, ang nagfe-fail dyan is yung bearing strength ng steel plate. Hindi bearing strength ng connector. Okay, so anong nangyayari dun sa steel plate kapag nagfe-fail siya against bearing? Dalawang klase ang bearing stress failure. Una is kapag lumuwang yung bolt hole. Okay, so ito yung hole deformation. Kapag lumuwang yung bolt hole, this is hole deformation. So anong capacity? Ano yung nominal strength ng connector? when hole deformation occurs. So as per code provision, the Rn, ito yung Rn niya. No? Yung Rn na yan is equal to 2.4 FU dt. FU is the ultimate tensile strength of the steel kasi siya yung lumuwang eh. Diba? Yung bolt hole is nasa steel plate. So FU ng steel, tapos yung D is the diameter of the bolt. Kasi yung diameter ng bolt mismo ang nagpapaluwang. Tapos yung T dito is the thickness of the steel plate. Okay, so 2.4 FU D times T. Okay, again, that is the RU for hole deformation. Rn. That would be the Rn for hole deformation. Pangalawang posibleng mangyari due to bearing stress failure is shear tear out naman. Anong sabihin pagka shear tear out? Hindi lang siya basta luluwang yung hole mo, sa halip pipingasin ng bolt yung plate. So, ideally, kapag ito yung bolt mo, pagka piningas niya yung plate, ganyan yung pinaka-failure niya. Itong portion ng plate ang mapipingas. Usual yan, actual. Pero to make it theoretical, if this would be the hole, this would be the area of the steel plate to be turned out. Rectangular na lang to make it simplified and theoretical. Ayan, yung sa figure letter B. Ito yung shear tear out. Nangyayari to more than sa hole deformation. So pagka mild pa lang yung bearing stress failure, hole deformation yun, lumuluwang lang. Pero pagka grabe na yung bearing stress failure, okay, so hindi lang basta lumuluwang, kung hindi, tinitear out niya yung pinaka-plate. Okay? So, ano ang nominal strength para sa shear tear out? Okay, ano ang nominal strength para sa shear tear out? Ito yun, 2 times 0.6 of FU. Yung times 2 dyan kasi, diba, yung taas tsaka yung baba. Yan yung mga sheared area eh. Ang shear tear out is shear failure. So, kailangan mo ng dalawang area. Yung area sa taas tsaka sa area sa baba. Kaya times 2 yan. Tapos as per code provision, it's given to be 0.6 of FU. Again, yung FU dyan is yung FU ulit ng steel plate. Tapos may LC tayo dito. LC times T. Yung T is the thickness of the plate. Ano yung LC? Ito yung LC, ito yung length na nasi-sheared off. So, tingin ka dito sa figure letter B. So, yung LC natin, ito. Yan yung distance from the edge of the hole. Ulitin ko. From the edge of the hole to the edge of the member. So, yun yung LC. Okay? So, yan yung LC. So, 2 times 0.6, kaya siya naging 1.2 na rito, times FU, LC, times thickness T. So, ito naman yung Rn para sa shear tear out. So, di bali, ulitin ko kapag ka bearing stress failure, dalawa ang possibilities. Pwedeng magkaroon tayo ng hole deformation, okay? Pwede rin tayo magkaroon ng shear tear out. So, paano mo malalaman kung sino sa dalawa yung mag-govern or mag-o-occur? I-solve mo yung Rn nilang dalawa. Tapos i-compare mo kung sino yung mas maliit. Whichever is smaller between the RNs of these two possible failures on bearing, hole deformation or shear tear out, kung sino yung mas maliit na RN, yun yung mag-govern na failure against bearing. Okay, so take a look at this figure on the right side. Okay, so if you consider bolt number 2, okay, so ito yung bolt number 2, okay? So, ang tear out niyan is from the edge of the hole, so here, papunta doon sa edge of the member. So, ito yung pinaka-shear tear out ng bolt number 2. So, ito yung LC niya. Okay? Now, anong relationship ng L sub C sa L sub E? Ano yung L sub E? Ito yung L sub C. Clear distance in the direction parallel to the applied load from the edge of the bolt hole to the edge of the adjacent hole or to the edge of the material. Yung L sub E naman is defined as the edge distance to center of the hole. So, anong relationship ng LC sa LE? Okay, yung LC is just equal to LE minus D hole divided by 2. Diba? So, yan yung mangyayari sa LC natin sa bolt number 2, LC2. LC2, tawagin ko to LC2. Kasi tawagin to LC1 mamaya. Okay? Now, ano yung LC1? Pagka sa LC1 naman, okay, so LC1 naman, ito naman yung whole tear out niya. Ito yung mati-tear out sa bolt number 1. Ito yung kulay pula. Ito yung tear out sa bolt number 1 naman. Okay, so LC1 can be calculated as, ito naman spacing S. Pag sinabing spacing ng bolt is usually, ano yan, center to center between bolt holes. So that would be, ano ba, spacing S minus D hole. Diba? Kasi kalahati dito ng D hole, tapos kalahati rin dito ng D hole, dalawang kalahati ang ima-minus mo sa S, kaya isang buong D hole. So, yan yung pagkuha ng L sub C. Nagagamitin mo rito sa equation ng L sub C rito. If you will notice, ang L sub C are functions of the D hole. O, ano yung D hole? O, balik tayo sa module 1. Ito yung mga D holes natin, di ba? Kapag yung bolt diameter is less than 24 mm, ang D hole natin is plus 2 ng D bolt. Kapag yung diameter ng bolt natin is 24 mm and above, ang D hole natin is equal to D diameter, D bolt, plus 3 mm naman. So, gagamitin pa rin natin yan yung ginamit natin sa module number 1.